All right, y'all, you made it to the end of chapter 6. This is 6.6, solving radical equations. Last video and last ed puzzle in the chapter 6 sequence. So let's check out what we got here. We're basically bringing radicals and equations together. Let's review a little bit. We got to square the following expressions. So if you want to take everything above the line, I want you to square. What that looks like is x plus 1 squared would be like this. You write it with parentheses, and then you've got to FOIL it out. X plus 1 times x plus 1, when you FOIL, you get all those terms, the f term, the o and the I term, and then the L term. Or you could say this is a plus b squared, and this is a squared plus 2ab plus b squared. You don't have to do all that nonsense over here because 4k is just one term. 4k squared is going to be 16k squared. The exponent distributes to the 4 and the k, and you're done. No addition. There's only one term right here, so therefore you can just distribute. Here we do have two terms, so if you're squaring it, then you write it like this, and then this is a minus b, so this is a squared minus 2ab plus b squared. If you don't remember the formula, you can always FOIL it as well. 2y times 2y, and you get these right here after combining the like terms. 3x squared, well, if you want to square that, that's just one term, so the 2 actually just distributes to the 3 and to the x squared. You get 9x to the 4th. Here, this is a little tricky. You get the square root of 3a minus b plus c, and technically it's all one giant term, kind of grouped together by the radical. I know there's three terms on the inside. There's the 3a, there's the b, and there's the c. They're separated by addition and subtraction. But generally, if you're going to square this entire chunkin' thing, it's all one monster term. So therefore, you don't need to FOIL. You can just say the square root of this squared, you get this right here. They'll cancel out, assuming that everything is positive. Okay, so with that in mind, basically we're reviewing this because later on we're going to be squaring expressions, and sometimes you'll FOIL like here, and sometimes you'll distribute like here. Then you got to know when to do each kind. So if you have a binomial or something larger than that, then you'll FOIL, or you'll use the formula a plus b squared. And then if you use just one term, it looks like this. And if it's a square root, then it'll look like this. You'll treat the square root as one term. All right, solve and check your answers. Squaring both sides of an equation. Okay, here's a new announcement. Squaring both sides of an equation mathematically requires checking solutions. So I've always said that checking your answer with a solution is good studentship, but now it's not just going to be good studentship. You've actually got to mathematically do it. The mathematics are going to require it. Let me show you. Okay, so x squared is equal to 4. And so if you're going to take the square root of both sides, you actually get plus or minus 2. Because there are two numbers that fit this equation. Plus 2 fits, and minus 2, negative 2 also fits in this equation. Now, squaring both sides, this is the opposite. You're not going to take the square root of both sides. We're going to undo the radical by squaring both sides. So the square root of x is equal to 4. If you square both sides, you get rid of that radical, and you get x is equal to 16. And so you've got one solution. Let's check to make sure it is a solution. You get 16. You put 16 back in the original, and yeah, it does work out because the square root of 16 is 4. The only time, this is super tricky, the only time you need to introduce a plus or minus is when you're taking the square root of both sides. We're doing the opposite of that here. We're squaring both sides. Let's solve the exact same equation over here. Square root of x is equal to negative 4. And you can see, let's do the same thing. We can square both sides to get rid of the radical, to undo it, and you get x is equal to 16. Because negative 4 squared is positive 16. Let's check the answer in the original. All of a sudden, whoa, rocks my world a little bit, because you got the square root of 16 does actually not equal negative 4. It doesn't. We did everything right. We did all the algebra we needed to do, and all of a sudden we produced an answer, x equals 16, as we produced a solution that's not even a real solution. It doesn't even work when you put it back in the original. So what I'm saying is this: you are actually mathematically required to check your answers, because you could do everything right and follow all the algebra you want and all the algebra I teach you, and then actually get to answers that don't work in the original equation. Wow. So we got to check. I know that might sound a little frustrating, and the good news is I'm going to show you towards the end of the video a shortcut that will work all the time. If you can find the shortcut, then you don't really need to check your answers. But if you don't spot that shortcut, you don't get good at spotting the shortcut, then you do have to check your answers. All right, let's check this one here. Square root of b minus 4. I see subtraction. I see square roots. Let's undo the square root first by squaring both sides. You get b minus 4 is 25. Then b is equal to 29. All right, so therefore, I think the answer is 25. Let's check. The square root of 25 minus 4 is, yes, indeed, it is 5. So the answer is 29. Let's check this out. Square root of b minus 4 is equal to negative 5. It's the same thing, just changing the 5 to a negative 5. Let's square both sides to undo the radical. We get b minus 4 is equal to 25. And then add 4 to undo the subtraction. We get b is equal to 29. Is that an answer? No, it isn't. Because 29 minus 4 is 25. And you take the square root of 25, you get 5. You don't get negative 5. So there are no solutions to this. Oh, the symbol for no solutions is right here. If you're the kind of person who likes to write symbols and not words. All right, let's keep going. So here, we are not required to check our answers because we're not squaring both sides for anything. Okay. When we add 5, when we undo the subtraction, we get 12. Undo the multiplication here. Undo the square. By taking the square root of both sides, we have to remember that plus or minus 2. That both of these numbers will work here. Let's check this out. We've got addition inside parentheses, multiplication, and subtraction. So what we've really got to do is we've got to get rid of all the, we've got to peel back these operations one at a time. Undo the subtraction, undo the multiplication, undo the addition. We get square root of x is equal to 4. To undo the radical, we've got to square both sides, and we get x is equal to 16. Because we squared both sides, we have to check the answer. So we didn't do that here. We squared both sides here. So when you square both sides, you have to check the answer is 3 times 1 plus square root of, what is x again? Oh, x is 16 minus 3. Does that in fact equal 12? Yes, it does. Because 3 plus 4 is 5 times 3 is 15 minus 3 is 12. Yay. Great. Let's solve another equation right here. Let's undo the division to get this. Let's undo the addition to get this. And now we have square root of x is equal to negative 7. And we square both sides, we get x is equal to 49, positive 49. Let's check, and we think that's an answer. Let's check to see if that really is a solution. So we get, let's put it back in the original, 1 plus square root of 49 over 3. Does that in fact equal negative 2? Nope, doesn't, because 1 plus 7 is 8 divided by 3. That is not negative 2. There are no solutions to this equation. There's no number that you can put in for x to make all of this equal to negative 2. Let's keep going. Let's keep practicing. Here, square root of 3x minus 5 plus 2 is equal to 6. Let's get rid of everything outside of the radical first. That's like, let's undo this addition because it's outside of the radical. And we get the square root of 3x minus 5 equals 4. Square both sides, we get 3x minus 5 equals 16. Undo the subtraction, undo the multiplication, you get x equals 7. Now, we think that's an answer. Because we squared both sides of an equation here to get rid of a radical, we have to check to make sure that it's actually an answer. So we put 7 back here in the original, and boom, 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 boom. There it is. Good. Great. Here, let's do this one. Now, you and I both know that a fractional exponent is the same thing as a radical, so this is the cube root. This will be 4 times the cube root of 3x plus 6 minus 9. Undo the operations on the outside first. So add 9, divide by 4, you get this. Now we have a radical to undo. Let's raise both sides to the third power. And actually, we're not required to check this answer because it's the third power, it's not the squared. I'm going to check it anyway. It's good studentship. But when we raise this to the third power, 3 to the third power is 27. And all of this to the third power cancels out the exponent. So you have 3x plus 6. And when you subtract 6 and divide by 3, you get x equals 7. And notice it actually does work as in the original. 3 times 7 is 21, plus 6 is 27. Take the cube root of 27, that's 3. 4 times 3 is 12 minus 9. Yes, in fact, it is 3, so it works. Here's a sixth. Okay, 2/3 times all this raised to the 1/6 power. That's like a radical to the 1/6 power, the sixth root, plus 8 equals 10. Undo everything on the outside. So we'll undo the addition first, undo the multiplication next. But I can multiply by 3 over 2 to cancel out the fraction. So we get this. And then I'm going to raise all of this to the 6th power. 3 times itself 6 times. 3 times 3 times 3 times 3 times 3 times 3, 6 times, is 729. Undo the addition, undo the multiplication, get x equals 65. And we do have to check it because the 6th power isn't even. You don't have to, we have to, anytime you raise something to an even power, like squaring it or fourthing it or sixthing it, then you have to check your answer here. Let's do something here. This is 5q to the plus 1 to the 1/4 power plus 7. Okay, just knowing that this is a radical, it's the 1/4, we're going to have to check our answer because it's 4 is even. So undo everything on the outside, that's the addition, undo the addition, and then here we get this. And now we have to raise all this to the 4th power. So to undo the exponent, which we can see here gets undone. -2 times itself 4 times is positive 16. Undo the addition, undo the multiplication, you get q is equal to 3, and we got to check it. We think that q is equal to 3, so 5 times 3 is 15, plus 1 is 16. 16 to the 1/4, well, what number times itself 4 times is 16? It's 2. So 16 to the 1/4 is 2, plus 7 does not give you 5. 2 plus 7 is 9. So therefore, there are no solutions to this equation. Here, let's talk about this next one. Okay, so here, the new thing is that we've got square roots on both sides of the equation. And we have to remember what we reviewed at the very beginning. In order to get rid of the square root, we're going to square both sides. And you can see this squared gives you this. And so this squared, there's actually 2 terms here. You can't just say this is distributed to the exponent of 2 to the 1 and the exponent of this here. Because there are 2 terms, you got to FOIL it out. Or you have to remember a minus b squared. This is, if a is 1 and b is square root of x, and this is a squared minus 2ab plus b squared. Okay, good. So actually, this is progress because we went from 2 radicals down to 1 radical. Let's keep going. Let's combine all the like terms, and actually, the goal here is to get the radical all by itself. So I'm going to move the 1 over. This becomes minus 10. I'm going to move the x over. They cancel. Subtracting x from both sides, they cancel. Then I'm going to divide both sides by -2. We get -10 divided by -2 gives you positive 5 is equal to square root of x. To get rid of this radical here, we've got to square both sides. So this becomes 25 equals x. Now, because we squared both sides a couple of times, we have to check to see, does 25 actually work in the original? So this is going to be square root of 25 minus 9 is equal to 1 minus the square root of 25. Is the square root of 25 minus 9 equal to that number minus 25? Yes, it is. And I'll leave it to you to figure out what is underneath the red dot. So 25 is a solution. Let's do this right here. Okay, we've got 2 radicals. Just from experience, I know that I mean, you're allowed to square both sides at this point, but I think it's actually going to be a little bit easier if we move one of these radicals over to the other side of the equation. It simplifies it by a step or 2. And it's not required, but you can do it if you want, and I recommend it. I like doing it this way. So just to reorganize things and make squaring a bit easier, I'm going to move this radical over to the other side. Doesn't matter which one you do. So I get square root of x plus 5 is equal to 1 minus square root of x. I'm going to square both sides. This is a single term. Remember, the square root groups it into one term, although inside the radical there are 2 terms. There's an x and a 5, and there's 2 terms. But this entire radical is one term. So it looks like this, and when you square it, you actually remove the radical, which was kind of the point in the first place. Then we're going to square these two terms here. Now, there are two terms. It's a 1 and a square root of x separated by subtraction, two different terms. So that means we have to remember a minus b squared. This is going to be a squared minus 2ab plus b squared. And if you forget the formula, like I said, you can always FOIL it. 1 minus square root of x times 1 minus square root of x. I'm going to, very much like I did in the previous problem, I'm going to isolate the square root of x and get everything else to the other side. You can actually subtract x from both sides. They cancel out. You can subtract the 1 from both sides. You get 4. And very similar to the previous one, we get 4 is equal to negative 2 square roots of x. And I'm going to divide both sides by negative 2. And here we go. We get negative 2 is equal to the square root of x. In order to undo this radical, I have to square both sides. So that negative 2 squared is 4, and that equals x. So 4 equals x. We think that's the solution. Let's put it into the original. Square root of 4 plus square root of 4 plus 5. Does that equal 1? Well, this is 2, and this is square root of minus 3. So 2 plus 3, does that equal 1? No, it doesn't. So therefore, there are no solutions to this equation. There's no value of x that will make this equal to 1. All right, so time for some big ideas and the big shortcut that I promised. First of all, when squaring both sides of an equation, you've got to remember that one term distributes and many terms FOIL, or a plus b squared. So, like right here, it was really crucial right here. This was one term, and this distributes to the square root, and they cancel. This is two terms, and they FOIL, and so you can see it looks like that, which is kind of a tricky thing to think about, and something we have to practice and get used to. Here's the next big idea. When you're squaring both sides of an equation, then you got to check your solution to prevent reporting extraneous solutions. An extraneous solution is a solution that you produced algebraically, but actually doesn't work in the original. Like you followed all the rules, you did everything right, and you found an answer, and that answer actually isn't a solution. So you have to check your solution when you're doing this. Now, it's not just true for squaring, it's also true for all higher even powers. So anytime you raise an equation to the 4th power or 6th power or 100th power, you have to check your solution. Now, for the big shortcut. Equations in this form, the radical, even radical of anything equals a negative number, have no solutions. And now these red arrows are going to come into play. At each point in this, any time that we had no solutions, there was always a step before it where we got to this format. The square root or the 4th root or the 6th root or the even root of anything equals a negative number. And here it is. Square root of x is equal to negative 2. At this point, we can realize there's no way you can take the square root of any number and get a negative 2. There's no possible way. There's no number. So at this point right here, you can recognize, wait a minute, there's no solutions. I know that's not much of a shortcut here, but it is a shortcut earlier. Like, look at this. This is an even root of something is equal to a negative number. At this point, we can say, after one step, after simply undoing the 7, we don't have to move on any further. We can just say, oh, there's no solutions. Here, when we got no solutions, we undid the 3, we undid the division, we undid the addition, we got square root of x is equal to negative 7. There's no number where you can take the square root of it and get a negative 7. Square roots only yield 0 and positive numbers. Here, a square root of x is equal to negative 4. We could have just said that right at the outset, that you can't take the square root of any number and get a negative number. So there's no solutions. And even here, we just read it, look at it, and say, square root of this is equal to negative 5. No solutions. So y'all, that's your shortcut. And it comes up a lot, and let's practice and get used to it. So, and before I sign off, I just want to say that I want to tell you what my favorite coffee is. And all of you, I see lots of you with your coffee beverages coming into class, and that's all well and good, and you're welcome to have them. But my favorite coffee is no coffee. I can't stand it. You're allowed to eat coffee and drink coffee and have coffee flavored ice cream and all that stuff, but for me, it's a gag reflex. Can't stand it. That's why I need to wake myself up other ways in the morning. So take care. I want you to tell me about your favorite coffee beverage when you get to class, and I'll see you in class. Thanks for sticking around.